So, simplifying each expression. What does that mean for logarithms? Well, in each of our equations up there, if we can write things as a single log, we're going to say that it's simplified. So in the first one, we have log 7 plus log 8. Here we're adding two logs together. Now, an important thing to notice in our formula, and if I use the formulas that, wow, there's log A m n the first thing I want to point out with this formula is the formula only works if the bases are the same. So the formula only works if the bases are the same. Now that's the same thing, and that's the same truth as we have with our exponent laws, right? The only way that you could add exponents is if the bases are the same. If the bases were different, there's nothing that you could do. You would just say, well, it's just 3 squared times 2 to the 5. I can't do anything with that. But the bases have to be the same. And the same thing is true for logarithms. So in our first question, part A, what are the bases? The bases are 10, because that's the common log. So even though the base isn't written, we know that that's a base of 10. And so we can say, hey, this is our log law of the two things adding. I can write it as the left-hand side, and this will just be log 7 times 8, which is equal to log of 56. And if you were to estimate log of 56, what number would you think that's close to? So again, what is our definition of a log? Definition of a log says log solved for exponents. The base is 10. So this question, log 10 to 56, is asking 10 to what power would be 56? Well, and since we know 10 to the 1 is 10, 10 squared is 100, it's got to be somewhere between 1 and 2. So I guess a good estimate would be 10 point something. There we go. That seems like a nice estimate number, 10 point something. Now we might say, well, it's at 56. 56 is between 10 and 100, so we might guess 10.5. But we'd have to go to our calculator to actually see how close that estimate is. But as far as what we should be able to do when we're estimating, you should be able to say, oh, 10 point something, not 10 point something. 1 point something, right? There we go. Whew. It's Monday. So we should be able to say it's 1 point something, not 10 point something. Because we're solving for an exponent. We're saying 10 to what power is 56? It's got to be between 1 and 2. Okay, part B. Again, every time that we're asked to simplify, we want to change our log laws from the right-hand side, as they're listed, to a single log as the left-hand side. So right now, this isn't a single logarithm because there's a 5 out in front. Now, writing our log laws from over there, we have a log law that says log base A of m to the n is equal to n log base A of m. Again, on this equation, there's only one log on each side. Okay? So on the first one up above here, we had 2 logs on the right-hand side, log am plus log an, and there it was really important that the bases were the same. This one, you're not going to have to worry about the bases just because there is only one log listed. Now, what this log law is saying is whenever you have a number out in front, you could put that inside of the logarithm by writing it as an exponent. So in this case, where we have 5 log 2, we can write that as log 2 of 5. And if you multiply that out, you get log of 32, which is the same answer as the one before because it's also 1 point something. Well, not exactly the same. And the last one was subtracting is looking at this log law. Again, in order to use this log law, we notice the bases have to be the same on the right-hand side in order to combine it. Again, we're using the common log here. The base in both of those is 10, so we can write this one as (80 divided by 16) which simplifies nicely to log 5. And log 5 is an estimate. 10 to what power is 5? It'll be 0 point something, because 10 to the 1 is 10. And 10 to the 0 is 1. So it's got to be between 0 and 1. Okay, try 4 and 12 right now.